There'll be a bit more ado as I set up my computer, so hang on just a second. Okay. All right, so my name is Chris Heiser. I'm the CEO and co-founder of Renovo Auto. We're a company that's focused on one thing, and that is bringing fully automated vehicles to the largest scale possible as quickly and safely as possible. My personal background, I went to Carnegie Mellon and studied engineering and robotics there many years ago. I was lucky enough to work at IDEO Product Development here in the Bay Area. I've done a number of tech startups. My last startup, we invented the camera phone and popularized that. But this startup is something much bigger. We are going to help transform the way we move people and things through large urban areas. It's a really important challenge. I'm lucky enough to be joined by a fantastic team of partners in this. We are a series of executives with experience in both automotive as well as technology, hardware, and software from companies like Apple and Google and Intel. And that's very important because the technology platforms that we're building for Robotaxi need to understand how to work with automotive, but they are very different, and they have very different requirements than existing automotive software and hardware systems. And so that's an important part of what we do. I have a couple of videos I'm going to share. The first one is a little bit from our roots. This is some work that we've been doing over the past few years with Stanford University. We are a research partner for Stanford in autonomous, and this is a program where we explore the limits of how autonomous can improve safety and control in vehicles. So this is a short video of Marty. Marty is a fully autonomous drift vehicle. So this vehicle drifts more accurately than a human. And more importantly, it forces the control systems to act about 10 times faster than they do in a production car. So Renovo supplies the software platform to Stanford, and they build their self-driving systems on top of that. This is a video of a vehicle doing complete transition from a counterclockwise to clockwise drift with no change in between. So this is the first robotic vehicle that's able to do this on asphalt. And as you can see from the video, it does it extremely accurately. And it puts our software through the paces, so we learn a lot. This is something like motorsports or some advanced development that an automotive supplier or OEM might do. We do at the track as well. We have great partners in Brembo as well as Bridgestone. They supply the tires. They last 90 seconds on the car. But I think ultimately it's the data and the experience that we get from our relationship with Stanford that's the most important. And so we have other relationships with companies, and we work to take that software and build it up into a comprehensive platform for commercializing self-driving vehicles. And so this is another video which highlights a reference platform of ours that's based on the FCA Pacifica. This is a fully autonomous vehicle that has 16 cameras, 6 LiDARs, all of them from our friends at Velodyne, and they work really, really well. A 3 kilowatt computing stack. We use silicon from companies like NXP and NVIDIA and Intel, and a huge amount of capability. And we use this platform to integrate other people's software. What we're building is a platform that allows a wide number of partners to collaborate to build something together. And this is not very common in the automotive industry today, but as we go through this talk, we're going to make the case that it is important to collaborate because the goal, what we can achieve through collaboration, will be the largest change in value in the automotive industry since its inception. And that's a very important goal for us to have. So when we think about platforms, we see the vehicle as the next great platform. And in each big inflection point in our industry, whether it be server computing, cloud computing, mobile computing, and now autonomous or automated computing, there's needs to be software platforms that emerge that allow interoperability and openness, and that's something that we focus on. And so for us, the lack of a platform today is a challenge to commercialization. And presently, the platforms that exist are either inside of a single OE or are limited to a certain number of players, and we fundamentally think that's slowing us down. So that's what Renovo focuses on. I'm going to talk a little bit about robotaxi here in a moment, but for my talk, for any good talk, I think there's 3 points in any talk that you should remember. For ours, the first one is that robotaxi is the largest opportunity for automated vehicles. I think this is starting to become generally understood, but I think even at CES this year, it wasn't totally clear. And so that's an important thing for us to talk about, that automated mobility is going to be a $1 trillion industry in the United States by 2030. It'll be around $120 billion by 2025. But more importantly, it's going to account for the vast majority of miles traveled inside of urban centers. If you think about that for a moment, the way you travel today and point to point is generally on vehicles that you own or maybe ride sharing today. That's going to completely invert itself over the next 10 years. And that is a massive opportunity. It's also a massive displacement for the people that build these things today. These robotaxi fleets are going to be totally driverless. They will not have steering wheels. They will not require the rider to engage with the system in any way. They will be geofenced. They will be limited in where they can operate. And this is actually an advantage to robotaxis because the amount of mapping and testing and development is much, much, much smaller than a vehicle that would have to drive, say, from coast to coast fully autonomous. These will ultimately be electric vehicles, not because they're subsidized, not even because they're mandated by the government, but because per mile, when you operate at high utilization, an EV is less expensive. And the fleets will demand EVs because it will allow them to have a lower total cost of operation. And that leads us to the fourth point. These will not be owned vehicles. They will be managed by fleets. These fleets will buy them in bulk from manufacturers, and they will be responsible for operating them on a global scale. So this is very, very different from the automotive industry today. And it's one of the reasons why these platforms are changing. So why do you want robotaxi? It's an economic argument. It's all about cost. Today, if you take a ride-hailed service from Didi or Get or Lyft or Uber, you pay about sometimes as much as $3 a mile. Your owned car in a city, the car that you own, costs you about 80 cents a mile to drive. You may not know that, but it's true. When you add up all of the insurance and fuel and depreciation and parking and everything, it's about 80 cents a mile. Robotaxis by 2025 will be around 30 cents a mile. And some of the research suggests they'll get down to closer to 13 cents a mile by 2030. So you're talking about a 5 to 10x reduction in cost per mile. It's also important to note that for ride hailing, most of the cost is the men and women that drive them. And when you remove those, something really magical happens for the investors of ride hailing. It becomes an actual profitable business. And until you do that, it can't. That the cost of the humans is too high. And you can look at the financial information about these ride-hailing networks and conclude this for yourself. So that's one of the reasons why companies like Uber and Didi and Lyft are investing heavily in self-driving technology because it is an existential threat to their long-term survival. So you look at it's a big market, $1 trillion. That's kind of a large number. So sometimes it's fun to sort of build it up from the bottom. There's a research group called RMI about a year ago did some really great primary research in Austin, which is a southern city here in the US. And they just asked people if there was a fully robotized taxi at $1 per mile, would you use it, and how often? And about 41% said they use it at least once a week, and I think 13% said that they would use it always. They would get rid of their car. When you just take that amount of driving, that's a $2.5 billion a year opportunity. To give you context on that, that's larger than the net revenue of Uber in 2015. That's one city. And it's probably only a few thousand robotaxis that accomplishes this. There's only about 15,000 taxis in the whole of New York City, Manhattan. You scale that up to the United States. Texas alone is a $15 billion industry. By 2025, the United States, $120 billion. So when you look at the opportunity for robotaxi, it's massive. And you don't have to take my word for it or the research people. GM agrees. They think it's an over $1 trillion a year opportunity when the vehicles get to be cost effective. And this is why they are investing so heavily in self-driving. This is from a presentation that GM did only about a month ago. So there is an understanding that this is a huge opportunity and it will transform. And so when we talk about automation, this is what we talk about. When most people talk about automation, they're generally talking about ADAS. This is the existing business today that OEs and Tier 1s build. And they're quite good at it. It's relatively inexpensive. It leads to much lower injuries and fatalities. It's a good technology. But the difference between an ADAS system, which runs on about 5 to 10 watts of silicon, and a fully autonomous robotaxi deployment like on the top of a Waymo or a Cruise is orders of magnitude. And this is not a technology that the OEs have developed internally. And it's mostly startups here in Europe and in China that are leading the way. And that is the reason why there's so many partnerships and acquisitions that have happened. I think one more point about robotaxi that's critical to understand is that no matter what you think of the technology, when it's going to be viable, how quickly, robotaxis will be commercialized before autonomous owned vehicles. And that is because the cost will be the same for each one of them. If a fully autonomous system costs $100,000 or $20,000 or $10,000, you still have to put it on a car. And if you are in the market for buying a car and there's a $10,000 option for something, you're probably buying a $100,000 car. There's not going to be a person that buys a $15,000 car with a $10,000 option. That doesn't exist in the automotive world. But the robotaxis, they can handle a very expensive piece of equipment, and that's because of their utilization. A robotaxi in an urban area is going to be driving more than 50% of its time. And so whatever the capital cost of that asset is, you're going to pay it off on a daily or annualized basis on how often it's used. Compare that to a vehicle that you own. It gets used 4% of the time. So from an economic standpoint, robotaxi is the only thing that makes sense as soon as the very first system is available, and it will make sense for a very, very long period of time, long before you see these systems in owned cars. And if it takes 5 years to deploy 100,000 robotaxis, by the way, that's about 1,000th of the fleet in the United States of total vehicles. If you deploy 100,000 robotaxis, you've probably solved transportation in the top 20 cities. So it's not going to take 10 years to deploy enough robotaxis to completely corner the market. And as these robotaxis roll out, for each robotaxi that hits the street, you sell 10 less cars in the same city. So if you just stop for a moment and you look at this and you say, the robotaxi technology will be available first, it will make more economic sense, it can be deployed faster, and it dramatically erodes and replaces the existing mileage on owned vehicles, now you would understand why the automotive industry is so freaked out about this. And this is why at CES 2018, terms like automated mobility on demand or mobility services was what everyone was talking about. And it's why some of these interesting partnerships are starting to happen between fleets like Avis and technology companies like Waymo and Google. And you're going to see more and more of these things happen. So I think I just said this, so I'm going to skip this slide. And this, maybe I just said this too, that the automotive industry is way behind companies like Waymo. Waymo is operating robotaxis right now in Phoenix. You can take a Southwest flight and like an hour and a half see one of these things on the road with no safety driver in the front of it. And that's going to happen here probably in this quarter or the next quarter. They're already testing these things in San Francisco with safety drivers. The regulations will pass in California to allow them to pull very, very soon. So this is happening at an incredibly accelerated rate. And the idea that you can wait 1 or 2 automotive cycles to pick up this technology is not a very good idea. The 10th generation Corolla came out in 2010. The 11th generation Corolla came out in 2016. In that time, Uber was founded and grew to a $60 billion company. 1 automotive cycle. So this is why things are changing. Point number 2, this is a lot bigger than the robot. So there's a lot of focus today on the automated driving aspect of robotaxis, on the robo part of robotaxis. And there's good reason for that. It's a hard problem. It's something that requires a lot of computational techniques and computing approaches that are foreign to the automotive industry, or really any industrialized industry today. And that's why you've got companies out there that are doing amazing things in the space, some of which have been acquired. Nutonomy was bought by Aptiv for $450 million. Zoox has raised $250 million about a year and a half ago at a post-money valuation over $1 billion. Uber's team is working very, very hard on self-driving, and GM purchased Cruise for around $600–700 million at the end of 2016. All of these companies are working on this, and we get asked, do you worry that there are too many companies working on self-driving? My answer is no, because self-driving isn't something that you solve globally for all cases immediately. And if you think about that, it's not likely that the team in Mountain View is going to be the leader in driving in snow or understand what livestock looks like in a LiDAR image or how to deal with a complete deluge during a monsoon. There is a really, really broad space for self-driving. And when you add driving in heterogeneous environments with other agents, cars, and the difference between cultural and legal aspects of driving, it is a fantastically complicated problem. And people will chip away at this. But more importantly for us, if you're a global company, if you're thinking globally, it's probably likely you're not going to have one self-driving partner. That if you're going to launch in Sweden, you'll have people that do Scandinavian driving. If you launch in China, you might be mandated to work with a company in China because it's an AI software stack. If you are in Europe, you might be mandated to work with multiple people because the EU decides that that's something that should be more fair. There are a lot of subtleties to how this is going to roll out. And there's a diagram that we spend a lot of time looking at Renovo, and it's this one. When you think about what a robotaxi has to do, it has to replace all of the human function in the vehicle with software. It's not just the driving. It's where to go, who to pick up, who to let in, when to refuel the car, whether or not it's dirty and needs to be cleaned, whether or not it's broken and needs to be serviced, whether to send one vehicle or another. And it turns out that there's a total unbundling of the stack that has already happened in our industry. There are people that just do mapping and do it really, really well. I think you will or have already heard from the DeepMap team today. You've got people that just do logistics, that just do routing. You certainly have giants that do things like ride-hailing. You have existing companies that do fleet management. All of these people have to collaborate. The idea that one company is going to just simply take all of this software and operational capability and verticalize it is not a tenable position. And even if it were, the people that collaborate are going to get it done faster. That's how you build big scalable systems in our world. So when we look at this space, each one of these nodes represents a need for interoperability. If you're a smart city, you might integrate with Singapore. It's talking about integrating with 10 different ride-hailing and self-driving companies, 10 of them. If you are Lyft, you're probably going to work across not just multiple self-driving robotaxis, but those in multiple geographic locations. All of these are complicated, and they're all based on sharing the data and sharing real-time information amongst all of these applications, and that's a big challenge. So again, this is the way we look at it. If you don't take my word for it, there was a great interview with JJ from Volkswagen about a week ago, and he talked about his 5-layer stack for Volkswagen. This is how Volkswagen is thinking about highly automated vehicles and robotaxis. And he starts with the self-driving as a fundamental piece, and on top of that, he puts themselves, VW, the manufacturer. But then on top of that, you have the fleet management, which is a separate piece. You have the demand aggregator, TNCs, and then on top of that, you have things like content and commercialization. So this is Volkswagen's strategy. We agree. We think this makes a lot of sense to us. And I think the one piece that's missing from JJ's discussion is how do you integrate that? Today, a Volkswagen is made up of 100 little black boxes on a CAN bus. That's not a platform you can integrate into. Volkswagen uses 4G radios to get small pieces of data off the car. These things generate 4 terabytes per hour per vehicle. There are big, big challenges of how to do this. And for us, what's missing in this picture is an operating system, a platform, a framework that allows you to integrate and plug these pieces together. And when you look at these vehicles, what they're going to be, the concept of a powerful platform starts to make sense. This is a reference platform that we operate. We have our own fleet of these, and we operate these on the behalf of our partners and customers. These are vehicles that have hundreds of embedded sensors and also dozens of high bandwidth sensors. Our total backbone on this vehicle is over 300 gigabits of information pass through the networking system in this car. We store 4 to 5 terabytes of raw data per hour. We exfiltrate that data to edge servers and push the high performance or the extremely high time sensitive data over to the cloud. This is a data center on wheels. I think it's a bit of an overused description, but it's actually true. And we're using data center technology from our experience to build these and ultimately to design the software platforms that underlie it. And so when we see this large heterogeneous group of people that have to collaborate to make a robotaxi actually be a product, we see a role for platforms. And I think there are some great ways to approach this. Some of them are being built inside of OEs or inside of tier ones, but ultimately we think those are not going to be successful. That the critical aspect of this platform has to be its openness. That as soon as you start to limit or mandate certain ways of doing things, you're going to lock out partners. And if you are a global industry and you want to launch this across the whole world, you need to work with different people. If you go to China, there are 4 companies in China that have licenses for mapping, and you must use one of those 4 companies. But outside of China, you might be using a different mapping company. How do you do that? You want to be able to interchange these systems and not build completely separate technology stacks for every region you go into. You are looking, from every person that plays in this ecosystem, you're looking for interoperability. And I think some of the best, most scalable systems on the internet and in mobile cloud computing have grown from this idea. Okay, so third large point is because of a lot of things I just said, the automotive industry needs to look outside itself to help disrupt itself. And working with car companies over the past 7.5 years, we have a huge respect for what car companies do. GM makes roughly the same, in the same ballpark of free cash flow, of revenue on a quarterly basis as a big company like Apple. But Apple keeps 30% and GM keeps like 3%. They're some of the most efficiently managed supply chains on the planet. They build incredibly safe products. They deliver a massive amount of value. But what they do is they don't move very quickly, and they don't like to change their technology basis. And robotaxi is definitely a different world for them. And so there's this impedance mismatch between the world of algorithm development and sensor development and this high-performance world and the world of even silicon and certainly vehicle platforms moves very, very slowly. And so you need people that can play on both sides of this. And I think the Silicon Valley has done a great job of still working with slow-moving things like silicon, but building massively flexible and scalable systems on top of it through software. You need people that can build service-oriented architectures that can deal with data levels, orders and orders of magnitude beyond anything that's been seen in the automotive market. You have to think about deploying software in the field and being able to update it. These are all things that are not native to the automotive industry, and you can see how upstarts like Tesla have completely changed the equation for their customers by doing something as simple as a software update. That's something we take for granted in our mobile phones, but doesn't really exist in the automotive industry outside of Tesla. For robotaxis, you will have to do that. You're constantly updating the maps, you're constantly updating the routes, you're constantly communicating with the riders, providing them services, delivering the content that they want. You need these advanced computing concepts. You need companies that are willing to innovate and try crazy things and build them and break them and see if they work. You need teams that are highly motivated and deeply believe in their mission and are willing to push very, very hard and sometimes into the wee hours of the morning. And so that's, at Renovo, that's what we do. Our platform is called Aware. That's the name of our OS for robotaxi. It is a high-performance platform. It runs across multiple types of silicon. It will work with any type of vehicle. And we are laser-focused on automated mobility, on robotaxis. And we enable both software and hardware partners to work together. We're building an ecosystem I'm looking forward to meeting you here and to talk to some of the companies in the back, because we want to see more and more people on our platform, and ultimately we want to see more and more people collaborating to bring robotaxis to scale. They will make the largest impact for cities in terms of congestion, in terms of pollution, in terms of safety, and in terms of delivering transportation to a much wider range of economic sectors than we do today with our point-to-point transportation. So one last thing is a bit of a note of inspiration. I've done a lot of product development in my life, and one of the big challenges is convincing people they want a product that they've never heard of before, and that's a little bit tricky. And so I feel for the smartwatch people trying to convince people to do that. I've got one, but I think they still got a little ways to go. Smart cooking devices, you know, that's you gotta really kind of, you know, have people see the light. Smart juicers, you know, you have to do a lot to convince people that this is something that they want. But the funny thing about robotaxis, about fully automated vehicles, is that 100 years ago in Scientific American, there was an illustration of one and a description of what it would be like if you rode in one of these. And in the 1950s, we were trying to make them work. The GM and RCA were building some of the first you know, viable prototypes. These used magnets in the ground to steer the cars. When you see robotaxis on the road today in my neighborhood, people get really excited about them. They want to use them. They want to be part of it. Don't believe anything you read in surveys that people say they're not ready for the technology. They are. They're ready to not have to drive, to sit back, to reclaim some time, maybe just to zone out or to get more work done, whatever it is. They're ready. The cities want it. And the technology is actually there. You're seeing it in Phoenix today. You will see robotaxi deployments in 2018 globally, and by 2020 they will be at scale in the lighthouse cities, in the initial cities. So it's happening. We don't have to convince anyone. We just have to finish building it, and we'd like to work with all of you to make it possible. And so thank you very much for your time.
Thank you, Chris. I got 2 questions for you.
Sure.
The first one is, what's the difference and advantage when we compare Renovo and Android Auto?
So Android Auto is actually a framework for integrating applications into the head unit, into the center stack of a vehicle. So there are some similarities between what we do and what Android Auto does. The big challenge is that when you're interacting on a screen, you don't have to worry about safety. You don't have to worry about the accessibility of those systems to people from the outside. You don't have the same level of automotive safety level that might be an ASIL A unit. The actuators of a car are ASIL D. And so our platform interacts and creates a service layer around all of the components in the vehicle. And that requires that we operate at the highest safety levels, and that means real-time operating systems and complete assurance that requests made by the applications are successfully honored by the low-level systems. So I think there's some similarities, but Android Auto isn't addressing the same market or the same challenge that we are. And in fact, our vehicles will likely have screens in them that have Android Auto or OpenCar or CarPlay or maybe all 3, because that content experience in robotaxis can be quite important to people that ride in them.
Got you. The second question is how to ensure the operating system security.
So that turns out to be not just about the operating system, but kind of an operational model for the whole fleets. And so this is a really important question and something that the theme for us is partnership. We need to work in partnership with a number of people to bring this to fruition. Let me give you an example. At some level, we're running on silicon that the operating system can't affect, and you saw this with Intel's challenges over the past month. That's a bug that can't be patched by software at all. So there are systems that we have to rely on the hardware level that need to be provably safe. We have to have our layer be provably safe, and then the applications on top of it have to also be certified. And so this is something that actually the automotive industry and the security industry are starting to collaborate to define standards for this. I'd say that it's definitely a work in progress for everybody, but it's something that if you're not worried about and you're not taking seriously, you're not on the way to production. So it is something we care a lot about.
Great answer. Thank you.
Okay. Thank you.
So next, let's welcome Jinggao Wang from Baidu Apollo. Jinggao is the head of Apollo platform and a senior director at Baidu. He has over 20 years of research and engineering experience with both small and large teams in automobile, autonomous driving, mobile OS. Before joining Baidu, he worked